Well, I know I normally start these videos out by saying good morning, but it's actually evening right now. It's about 10:20 Central Time on Sunday night. I have to leave pretty early tomorrow to catch a flight over to Salt Lake City for an event, and I just spent so much time thinking about the pattern. I'm like, I'm going to record this tonight, and I'm going to tell you what I'm thinking about. Now, this story is going to start and end with the Bermuda High, and as you get into your day on Monday, this is when it's sitting over Nashville, right? So this is an expansive Bermuda High. We're going to talk about this corridor being very wet and very stormy and what that's going to mean. The isolated storms that I do expect to form inside of the Bermuda High. But my top question remains the same thing. Where is that high going to be as we go through the next 60 days? And I'm going to focus mostly on July at the end of this, but I want to show you where we are with our thinking on this. So that's it. We're going to start and end with that. Now, as we think this through, I want to talk about what was going on under that high on Sunday. Look at the temperatures that we saw through here. Now, a couple of these places, like you can see here, where it's cooled off, that's just due to convection. That's due to storms. And you have the very powerful front that is sweeping through the northern plains and it'll eventually get through the Midwest, Northeast. It'll sweep across the country. But behind it, I mean, the temperature swing already in Montana this week has been enormous. And after witnessing several days, in the upper 90s, low 100s in the plains, there is some change coming here early this week. And I'll get to that in just a few moments as well. But as you all know, we had some pretty nasty weather over the weekend, especially on Friday. If we just look back and rewind the clock through 7 days of radar estimated hail, many of these storms were not only producing the straight line wind damage, which was kind of the big kind of headlines out of this, but we'll talk about that in a second, and also numerous tornadoes. But we also had, we just had a whole lot of hail with these thunderstorms as well. Now, I want to show you, this is from Indon. This is a part of the Mesonet that's across parts of North Dakota, which is where you are here. And you can see the winds from the system that came through on the 20th, which was Friday, which were absolutely ferocious behind the storm system. Now, I say behind because on the leading edge of the storm, we had powerful wind gusts, and on the backside of it, we did as well. And it is what you call a bow echo. And as it went through, it produced, let me take a look at these storm reports here. Let's blow that up a little farther. I mean, you can see 232 total reports. The vast majority were coming through here. And remember, these square boxes represent those high wind reports over 74 miles an hour. So there's a lot of damage here. And I want you to notice something. Do you see all the red dots that are right here at the very end? Those would represent the tornadoes. Now, why I want to show you this is because of what this thing looked like on radar. So have a look at this. On the right, I have radar reflectivity. That's what we're all familiar with. It tells us the intensity of the precipitation. That's on the left. Forgive me. On the left, I have radar reflectivity. On the right, which is over, sorry, my mouse does two different things here. But on the right, that is radial velocity. So this is a way by which we use the Doppler effect to essentially measure a phase shift based off of the light wave reflecting off of the drop. And if the drop is moving toward or away from the radar, that's all we're doing here. So we can turn that into a speed, a velocity. Now the velocity is relative to wherever the radar is. So it's either toward or away from the beam. That's why there's always a zero line, as you see right over here. I'm looking again at the right side. Now, as you look at this, we can measure what these are. That's what the bullseye is doing there. And there were wind gusts that were measured on radar. The closer you get to the radar, the closer to the ground we are here. But there were wind gusts that were 60, 70, 80 miles an hour, and a few of them were 100. Now, a couple of things to take note of. This had a classic, look over on the left now, bookend vortex on the back side of this. That's this spin up you see here. And the leading edge of the squall line, actually at the very end of it. In fact, I'm going to pause this at the very end. Sorry. Confusing myself with the mouse here. You see these little, if you look at the image on the left, you see these right here? Those little cusps, what do we call those? I don't remember, but basically what you're getting here is you're getting so much horizontal wind shear that you're spinning up brief tornadoes, gustnadoes, if you will, on the leading edge of this. But what you probably heard most about was the incredibly strong winds that followed this squall line. And I thought it'd be kind of interesting just to show you a bit about what that is before we dig into this forecast. So let's go ahead and make this full screen so you got a little more space. I love this Wikipedia cross-section of a squall line. So it's like you took a squall line, maybe think of it as like a birthday cake, and you sliced it down the middle and looked at the insides. So as you approach one of them, the first cloud you see is the anvil cloud, maybe some mammatus, and then the storm's shelf cloud hits you. Now, what's interesting about this is I got asked a great question. Oh, gosh, this was about a week ago. I was on the Mossy Oak podcast, and they just asked about, how much water's in these storms. And just remember this. Every square mile that you put down an inch, okay, if a storm puts down an inch over a square mile, that's like 17 million gallons of water, okay? Now imagine you take one of these things and you spread it across, I don't know, the southern half of North Dakota. As it moves forward, this thunderstorm literally, contained within it billions of gallons of water. And what's amazing about it is you get right underneath the main updraft, which is here, okay? That main updraft, the pressure beneath you is actually low. And that's because the heat inside the storm is supporting all of that water, reducing the atmospheric pressure. And then right here, where you see these, the heavy convective showers, high pressure, mature cell, this is where the air is descending and the pressure increases rapidly. So the pressure change underneath a thunderstorm is tremendous. Not enough, I don't think, usually to make your ears pop unless you're near a tornado, but boy, it changes a lot. Now on the back side of it, there's something called a rear inflow jet, and that's where the flow comes in and dives down, and that's what kicks the leading edge of this out, giving you the shelf cloud that sits out ahead of this. But there's this interesting thing that happens on the back side where you can even get low pressure to form right here. So after the storm goes through, the winds will shift directions and become very strong again, and some of these have what's called a wake low, and that wake low can be incredibly powerful. Now here's a neat way to look at it. There's the leading edge of the storm. This is basically where the front edge of the squall line is, the shelf cloud. Immediately behind it, you have what's called your meso high. That's where your first and most intense downdraft is going to be. That's where the rain is going to fall out. Behind that, though, in that stratiform region, this is like after the main line of storms passes and you get like this, maybe 30, 40, 50 minutes of showers with lightning and all that. That's back here. And sometimes on the backside of that, you get that wake low. Now, I say all of that because some of the really strong winds that formed here are actually measured in the wake low, not on the leading edge of the squall line. And this thing was nasty as it went rolling through. Now, with all that being said, let me teach you one other thing, because I think on this page, maybe it's on the Wikipedia page. Yeah, let's go one that way. Nope, not one that way. There we go. This is just another great example of what these storm cells often look like. And I mentioned bow echo and bookend vortex. It's called that because the leading edge of the storm looks like a hunter's bow being bent when the string is drawn back, right? So you want to be very careful about being at the apex of the bow right here. That bookend vortex, what looks like a bookend on a bookshelf, there's usually one to the north. That's the most prevalent. Sometimes there's one to the south down here. So that's all of that structure was being witnessed across North Dakota on Friday night. And it did a lot of damage. It also put down some precipitation. In fact, let's update this. Yeah, we do have the 10 o'clock data in. That put down a lot of hail, straight line wind, tornadoes, and rain. Meanwhile, on the backside of this, a much broader low has moved through parts of Montana and brought some of the first and most meaningful rain in a while to parts of Alberta through Saskatchewan. It's going to continue to move as we get into this early week. Now, can you see the Bermuda High becoming the Nashville High? Look at that streak there. Or look at the streaks here, or there. That's all flowing around this broader area of high pressure, which is now settled in to, parts of the Mid-South. And that's where we started the video. Let me show it to you again, right here. So we're going to watch storms roll the periphery of this. In fact, let's go look at where they are right now as I'm recording pretty late at night. There's storms inside of the high, which you can get isolated storms. There's some storms near Texas, the Panhandle, up in Nebraska, South Dakota, and look up here into parts of Minnesota and to Ontario. In fact, right now I'm in northern Wisconsin with my family. These storms are pretty far away from us, but we're still tucked away in this incredible heat. Now, if you look at the satellite data from today, take a look at this. This is Sunday again. Look at that. So I want to point out you can still get storms to pop in the Bermuda High, but they are hyper-local in how they deliver precipitation. All right? So please understand that. Now, outside of that, look at the storms in Mexico, well forecast. You saw that last week. Look at the storms getting up into New Mexico with the fires on the backside. Take a look at what's going through. Here's that low I mentioned, going out of parts of Montana and moving into parts of North Dakota. That's what's dropping the temperatures so dramatically. And we've got more information about the West coming up. I've got big questions about the Western United States temperature pattern and precipitation pattern heading into this upcoming forecast. So where will we be on Monday? So again, I'm recording this late Sunday night. So Monday, I'm going to watch that frontal boundary slide from parts of Kansas through parts of Nebraska, Iowa, Wisconsin, up into Michigan. We're going to keep an eye on this all the way into Ontario as well. That's Monday's severe storm risk, and here's Tuesday's. We're going to watch the western and high plains getting up to parts of Nebraska and Wyoming. But what you're going to note here is you just kind of see how this is lined out. That's when that high is going to have the ridge riding storms over the top of it. So this is what it looks like. That is a 7-day forecast released on Sunday, remember, from the WPC. I do not imagine it'll look much different from this. A lot of the precipitation you see here is from the low that's moving out of Montana as I was recording this, getting into this area, desperately needed rainfall. Everything else, all of this is related to the Bermuda high shifting over toward Nashville. Now you look at this, you see this hard cutoff, and this is what's going to be so frustrating about this forecast if you're inside of this. There's still going to be rain in there, just not everywhere. You're going to have storms that are capable of delivering heavy rainfall. You saw them on Sunday, right down here. And that's going to continue all throughout this week. But there's going to be places that are going to be missed by this. And that's what's going to start to cause it's going to be very hot. It's going to be very humid. It's going to be very uncomfortable for us and for the crops. And we got to ask that question, how long is it going to last? So the rain that's going to be on the backside of this, which is hitting Kansas, Nebraska, South Dakota, parts of Minnesota, Wisconsin, and Iowa, this has been an area that since January we had a lot of concern about. And we had concern about it. I mean, really, look at this. This is just over the last month. That same area is technically drier than average, not nearly as dry as the Pacific Northwest. And that's a part of the story here, okay? But it's been really quite dry there. And before those big storms rolled through here, we were dry in the part of North Dakota. We were dry in central South Dakota. While we're so wet down here in southern Kansas, Oklahoma, Texas, getting through the Mid-South into the Northeast. You know, this last month has continued to give us major ranges, disparity in precipitation across the United States. And what's so critical about those rains, let me just show them to you again. See where they're coming through? Look at that. Look at how that area lines up geographically with where we have these dry soils. So this isn't just critical, like this is mission critical to the success of the entire season rainfall that's coming into this area. Down here, this crop is going to get steamed under the heat. There's pockets of drought north of it that are going to be having to deal with major issues. And we're going to talk more about Texas in a moment. But take a look at the Northwest. Very, very dry, but cooler weather is now in place. So thinking all of that through, we're going to come back to our high pressure cells. I'm going to focus on the Bermuda high right now. So I click play. Let's watch where it goes. There it is over Nashville now into next weekend. Okay, flattens back out, comes out to the open Atlantic. But if you watch that, there isn't a whole lot shutting down that Bermuda high motion, just pumping moisture into the U.S. What I question is, after we get into the month of July, does it keep doing that or does it wander off? And I'm going to worry about that until I don't have to worry about it anymore. So listen to what I'm going to do here. I'm going to present a case of things that we're going to watch together. I'm not actually going to present to you a forecast at the end of this. Okay? I'm going to give you what you need to be paying attention to and why it matters kind of thing as we work our way through the rest of this. Because right now, okay, we're going to lose the Hudson Trough. We're going to watch the ridge that's over the east back off in intensity. And these troughs in the west, well, just take a look at where they go. Monday, Tuesday, Wednesday. You see how we're starting to break this down? Like, where did that deep trough over the Hudson Bay go? Yeah, it's out in the open Atlantic. We don't see such highly anomalous ridging going over the east. In fact, there's a little bit of a ridge coming into the west. Where are we in the forecast? This is this upcoming Saturday, the 28th. We then notice that the pattern is attempting to do something like this. And it's in all the models, dropping in some sort of a low here to start off early July. Okay, that seems to be there. And what I have big questions about is where's the axis of the ridge by the time we get into the month of July? And I would want to know if it's there, which would put this whole region under the risk of being hotter and drier, or is it here? And all I'd have to do is just redraw that. Would it be this region that would be under the risk of being hotter and drier? That's a simple way to kind of think about it. Now that's the European ensemble. Let's go look at the AI model. The AI model still favors this broad, long wave. See that thing? That's rolling through most of the North Atlantic. It actually part of this starts way over here. There it is. And then it just kind of comes through. But there is this weaker trough of low pressure that seems to sit over the west more often than not, especially in the near term, influencing this overall pattern. Thinking through that, I do want to show you kind of the global situation with this. So we're going to talk more about our ring of fire and then what's coming right down here very soon and how there could be a drier swath in between. I'll get to that in a second. But I just keep talking about Europe. Take a look at how dry Europe is, all the way over to the Russian wheat belt, how dry things are. Better rains throughout parts of southern Brazil. Take a look how wet it is in India, Indonesia. Manchurian Plain, a bit drier. North China Plain possibly as well, but I don't know if that's enough of a story right now. But I wanted you to see that. So back to the United States. This is the 22nd through the 27th, the first 5 days of the week. In fact, here's the first 7. So what do we see? We're going to have this ring of fire here as one low exits. And there's going to be isolated storms that happen in this area. But there could very possibly be a very dry region that sits somewhere underneath this that never catches that lucky break of having a storm. And maybe what you can see is in the day 4 through 10, that's when we have the better chances. As the Bermuda High, which was sitting over Nashville, tries to leave again, it opens the Gulf back up, and there's some more storms in this area. But over the next 10 days, sorry, I accidentally clicked on that. But over the next 10 days, there we go. That's what the overall pattern's shaping up to be. And there's a spot in through here that's looking at better than 2 to 3 inches of rainfall possible. So we saw that on accident. So let's go here. That's the 10-day probability of at least an inch. Okay? Now you can see this. See this? But watch out for this area. Then let's go out there to 2 inches. This is the probability of getting 2 inches. So for parts of Nebraska, Iowa, Minnesota, Wisconsin, and then maybe into the central part of Michigan, which desperately needs more rainfall. Okay, that area, could get a pretty good chance at 2. If you're curious, the probability on 4, this is a bullseye on Iowa. That's a lot of rain, and it can't be ignored. So there's another component to this I want to talk to you about, and that is the winds. If you just take a look, we've got still, again, very strong winds Monday in the central plains of the United States. A very, very strong wind event taking shape off the California coast. Look at that. But if these winds continue to kind of blow here for another day or so, it's what's keeping our evaporation rates relatively high. Now, they're not nearly as high as when I showed you this on Friday because we're through the weekend, and the weekend was hot and windy and dry in here. In fact, on, Saturday? Yeah, there was a big dust storm that rolled up out of central Texas. So these are down from where they were, and I realize now that I see this, I need to redo this map so that I can actually see the numbers over the lighter colors here. But that's your 7-day forecast of total evaporation. Since we're on these 7-day maps, this is the next 7 days looking at GDDs. So how many GDDs are going to get accumulated? There's still quite a bit of heat in this. And if you want to know stress degree days, that's what they look like. Now, the stress degree days have been coming down in the northern plains. That's largely thanks to the ridge that's shifting east and the trough that's coming in behind it with the cold front. But we're accumulating a lot of these stress degree days in this area. So that cold front looks like this on Monday. So like we talked about, there was going to be a 30-plus degree swing in temperatures just in the highs alone from late last week till this week. There it is. We're now down into the mid-upper 70s. Still very hot. East, Great Lakes, mid-south, parts of the Midwest. That's Monday. Tuesday, Wednesday, see the heat staying across the east? There's Thursday, Friday, Saturday. So when does this all back off? Because it certainly backed off up in the northeast, way up here. But what's going on here is we got to wait until we probably get to the beginning of July for that trough to develop to cool these things off, cool these temperatures off. I want to show you what it looks like using the European ensemble. That's the next 5 days of temperatures compared to average. And here's day 5 through 10. That's a lot of warmth. I'll tell you more about this in just a few seconds. Day 10 through 15, still looking pretty warm across a lot of North America. And we got to ask ourselves where this is going to be going in the longer term. So here you go. This is my explanation, but not a forecast, if you don't mind me doing that, because I got to get these ideas out. And we got to get them analyzed. And Matt and I spent about an hour and a half on the phone tonight just talking through this. Okay, we've showed you this, I don't know, a dozen times. That's the July forecast according to the European model. And it's looked like that. Nonstop. It's not really changed. It has had some sort of active southwest monsoon. It's placed a ridge somewhere here. It's had enough Bermuda high moisture to hit this area. And it's just got this corridor of dry. Now, you got to think about what that means when we look at this area and say drier. And so what I'm saying here is we need to make sure we understand climatology. So if you go look, let's blow this up a little bit. If we're trying to assess this, Texas, we've got you drier, but Julys in Texas are dry, right? A typical Texas, what are we? We're an inch, maybe 2 inches of total precip. All the wettest weather runs the periphery. Now look at Kansas. Kansas may normally get 3 inches of rain in July. Same thing for Missouri, Iowa, parts of it. I mean, look at this. Look at the Southeast. It's common to get 4, 5, 6 inches of rain in July. What's interesting is these anomalies in Texas aren't that far away from what you normally get. But in Kansas, that is something to be watching. Parts of Iowa, Illinois, if this verifies, that's significant. Look at this. We're off by, we're about a third lower than normal on precipitation. Now, if you perfectly time the precip events, it doesn't matter if you're a third lower in Iowa, especially if you get the rainfall that we're forecasting in the next 7 days. But we're trying to assess where these big subtropical high pressure cells are going. And as we work our way into July, I keep seeing this. The Pacific high anchoring here more or less, the Bermuda high here with a much, much weaker, pressure anomaly to its south. We got to talk more about that. And we're just trying to see if there is something to this global pattern that by the time we get to the end of July, we're looking at displaced subtropical highs. And if they do, that's going to give us more conversations like we just had. Like, is the Bermuda high in Nashville or is it in Ireland? Is the Pacific high all the way over toward Midway? I don't know. It doesn't look like it's going to be. Or is it going to be in the Aleutian Islands? Or is it going to be British Columbia? Those are all questions that have to be answered with this forecast. So this is what I'm trying to make sense of. I'm going to use someone else's forecast, and I'm going to show you what I'm watching. I saw this come out late last week. You saw it on Friday. That's the new CPC outlook for the month of July. And then here is the 3-month outlook, July, August, September. They're very similar. And if you notice, it's got this dryness that kind of sneaks down here, and we're wet in that area. Do you notice it's almost the same thing that the European model is showing? I just want to know why. What is driving this forecast? So I'm going to pick it apart, and I hope you enjoy this. I'm going to start here first. These are winds deep in the stratosphere at 10 millibars. And if you look along the equator, they are now strongly out of the east. We call this oscillation in these winds. Sometimes they go west, sometimes they go east. We call it the QBO. Now, interestingly enough, look at this. Last August through, March and April, see the reds in there? That is the QBO in its westerly phase, the positive colors. And recently, just now, see it? It's gone to its easterly phase. Now, if you're curious, we can verify this. This is what it looks like in the upper atmosphere. This is the stratospheric profile. This is over Singapore. It's a good place to sample this. And there you go. That's the easterly phase. Now, easterly phase we can also call the negative phase. And why I'm doing that is because I want to show you this. This is a correlation map of the QBO in July. Now, what's interesting about this is it places a ridge of high pressure here, a trough in the Gulf of Alaska, some sort of large ridge that just occupies, the central plains through the Canadian prairie, and low here, and look at that. Something more of a stronger Bermuda high in this area. So you're saying, well, Eric, what does that give you? What does this pressure pattern give you? It gives you this exactly. Now, I don't know if that's what the reasoning was behind the forecasters at NOAA when they put this together. Were they going, this is all QBO, easterly phase, negative phase. There it is. That's the high pattern. Let's go with it. Maybe. I don't know. Let's keep going. Ocean temperatures. Now, I like to show you two different kinds of ocean temperatures. The first one is comparing to today's average. So it's the global mean and looking at the regional differences. And I do this because I feel like we're getting better ideas on the contrast of this old decaying La Nina, the warmth that's from the western warm pool here, and the cooler water that's there. So this whole area I'm kind of shading looks cooler than average. In the Atlantic, we've got this going on. We're going to talk more about that in just a few seconds. But what I'm stuck on here is a few things. So here they are. This is the PDO, right? We've looked at this many times in these videos. At the very end of it, we're at a PDO value in May of minus 1.7. Now, are we there? Are we somewhere close to that? Maybe. Yeah, maybe we are. And if we are, what does that even mean? Well, historically, if you correlate the PDO values against heights, a negative PDO tends to produce troughs here and ridges there. That's a negative PDO signal. It tends to be really strong winds there that come up and they just dip right around that. I mean, that's what we tend to get. So that's a central U.S. ridge. We got to be careful with that. We could do something else. This is kind of a fun tool. I'm going to say let's go back and look at the trough ridge pattern, but I only want to look at those times when the PDO was below negative 1.5 for July. And when I do it, it's now just going to look only at the really low PDO values, and that's too large. There we go. And this is really interesting. It says in July, you do tend to get that strong, there's the speed of the jet, but there's part of the Pacific high. Maybe it's over here too. Bermuda high drifts, and there's high pressure there. And look at the years that it chose for this. So I guess my point is the PDO signal would say, hey, you better watch out for a drifting Bermuda high. And I showed you where it is right now. It's worried that it could drift off over here. All right, let's keep going. So we were there. Here, let's go back to this. Let's talk now about the PMM. That's this region. It's called the Pacific Meridional Mode. And as I look at that, these values are definitely negative. And, let's blow that up. We know that when we correlate this against that, we tend to get, look at that, ridging here, ridging there, and there tends to be low pressure. That's here and here. So that negative PMM, the cold water off the Baja, should point to a lot of heat in the plains, a lot of drought developing in this area. But it's not, right? It's not really doing that just yet. There are pockets, but holy cow, we're not seeing a drifting Bermuda high just yet. So is it later? I don't know. That's why we're getting these ideas out here late this evening. Then I said, well, let's go back to the PMM index. Tell me all the times it was less than negative 1. That's what we're going to do. Let's just do only July. And click that. There we go. This should pull up. There it is. Gosh. There's the Bermuda high. There's the trough of low pressure. There's some sort of a high in the middle. Now, it's not a guarantee it's going to be dry where the European model says it's going to be dry, but I'm just worried that at some point in July we're going to get this. I don't know. Being completely transparent. I have no idea. But I also have to look at one other thing. This is called the Atlantic Meridional Mode, or AMM. Now, it has a positive phase. When these water temperatures are very warm, we often look at it for what it can do to tropical systems like hurricanes. And then we've got the negative phase, where it's cold here and warm south. See that south of the equator. Now, you can make an argument right now. Look at this. We're warm here and cool there. We're kind of like a negative Atlantic Meridional Mode, if you will. So I went out and I said, well, show me what that means. So let's do this. Let's go Atlantic Meridional Mode, negative, I don't know, let's put it negative 1. Show me all the times it was less than 1 in July. And stitch those here together, make a composite. And again, what is this? All of these things are pointing towards some sort of ridging event that's in the North, Atlantic. And do you remember earlier? Where did I put that slide? There it is. We do not have that right now. I mean, the ridge is here and there. Oh, really? It's over Nashville. So this is what's interesting. All of these signals should point to a July pattern shift. And do they land us on this? I mean, or that? And how and when does that risk build in? I'm not done yet. I got one more for you. So we did this one. That's the one we just looked at. How about one last thing? This is ocean temperature patterns when you compare them to the historical averages, not today's average, but the historical average. And I go, well, I do see the negative PMM. I do not see as strongly the negative AMM, right? It's just not there. Yeah, there's been these easterly wind bursts here, but it's not quite there. And then definitely, look at all the warm water that's moved into this area. Look at the Western Warm Pool. You look at all that and say, well, are we dealing with like some dead, dying, flailing La Nina-ish pattern going on? Maybe. Have a look. If we look back, when did I do this over? 5/1 to 6/20. Boy, that's the Pacific high. There is the Bermuda high, just hugging the coasts of North America. But look at these stronger trade winds. You could make an argument that we're still getting La Nina-like weather. And maybe that's where I need to land on this, because I went out and I said, all right, show me July precipitation patterns when you have a negative multivariate INSO index. And you see these warmer colors? That is where it goes drier. So there's a positive correlation with it, meaning El Nino would be wetter here. Where was it wetter? Here and there. It seems as though NOAA's forecast is probably anchored in the decaying La Nina event that was powerful last winter. I think that's the story. That's got to be what they're doing here. So I'll finish with this. La Nina summers at some point tend to lose a lot of momentum. And we're still below average. And if we keep staying down here, I think that we could have drifting high pressure systems. Just not right now. It's not the end of June. The end of June, you just need to drill this into your head. Where was it? There it is. That's how you're going to finish the month of June. And can you buy enough rain here to last? Does this break drought problems in Mexico, New Mexico? How bad does it get in the West with the warmth that will be returning and how dry it's been already? I mean, you saw this. Look how dry it's been. And finally, if you're inside of the ridge, it's going to be hot. But are you going to catch a pop-up storm? And all of this is ahead of a hurricane season, which all of those variables affect too. So I'm going to go to bed and think on it, and I'll think more on it this week. Matt will take over for me for a few days while I'm out in Salt Lake, and Andrew will as well on Wednesday. I really appreciate those guys helping me out while I'm gone. I appreciate talking to you tonight. Hope you're all sleeping well and you catch us early in the morning. Thanks.